Okay, in this video I am going to talk about the inverse of a Laplace transform of integral. In the previous video we have I have talked about the inverse of a Laplace transform of a differentiation. Now it is time to talk about the inverse of a Laplace transform of an integral. So let's start our discussion. Okay, so we'll cover this concept from basic to advanced, so don't skip a second for this video. So let's start. Laplace transform of f of s equal to f of t, then s to infinity Laplace transform of s ds equal to. So it is nothing to prove here, so that is our main concept here, that is we have to find it here. If Laplace inverse of f of s equal to f of t, then inverse of s to infinity f of ds equal to ft by dt. Okay, so that is our concept. So find the Laplace transform. Here we have a question, so find the inverse of, oh my god, arts of integral s to infinity s plus 1 ds. That is our, we have to find that inverse of f of t. Here f of s equal to, you can see, s minus s plus 1. After integration by partial fraction, it gives us s minus s plus 1. So it gives us the inverse of f of s upon 1 by s plus 1. Okay, so which give us 1 minus e minus t. So here we have to find the integral. So we get f of s f of t equal to 1 minus et. So integral 0 to 1 minute s to infinity f of s ds equal to, will give us f of t by t. So it give us e minus t upon t. Okay, so that is our application. So note down it. Let's look at another question. So if we have done. So now let's look at another multiplication. That is the basic concept. You can find it. Multiplication of s, multiplication by power of s, or of s. If f of Laplace transform of f of s equal to f of t, okay, then inverse of s f of s equal to f dash t. Okay, in general we can say that that is the part 1 theorem of part 1. If f0 f dash 0 f0 f dash 0 f double dash 0 equal to f down n minus 1 0 equal to 0, then in general inverse of s f of s equal to f and t. So that is our theorem, which is the generalized theorem of this. So it is, you can easily prove it, so I am not going to prove. So let's look at it. So that is the theorem. You can prove it by finding the Laplace transform of f of n, then take the inverse and put it equal to 0. As we have the condition f of 0 equal to what? f0 f dash equal to all the derivative of a function equal to 0. Then it will obviously give the result of that. That is the result we get. Where I have written that result we get. Okay, that is our main concept. So wrote down it. I am done. So if we have done, that is our f of n t equal to dn by dt f of t. That is our result. So we are going to solve the some question. So Here we have a question. Evaluate the inverse of s upon s square plus 4. Okay, here you can easily see that f of s equal to what? S. You can find it obviously. Let's do it another way. Okay, s upon s square plus 4, which can be written as s square plus 2 square. Okay, so that is the Laplace transform of what is the inverse. Now find the inverse of f of s. Okay, okay, now what is the formula of this? This is the formula of cos 2 sin 2t sin cos 2 t. Okay, here since cos 2t, okay, so here it multiplied with, that is our function f of s, so it is multiplied with s, so that gt, let's it suppose gt equal to what? S square plus s plus 4, so it is s upon f of s. So inverse of f gt will give us, that is the differentiation of f, so d by dt cos 2t, which give us 1 by 2 sin 2t minus, okay, 2t that is the question. Now we have to move in the second part of this. So if it case say that f of s equal to s square, so what we have to do? So here f of s equal to, we can easily say that s square plus 4. Okay, so that is our differentiation. Okay, so d by d s f of s equal to what? D by ds upon s square plus 4, which give us minus 2s upon s square plus 4 to the power whole square. So here, since it is positive, so it will give us 1 by 2 d by ds f of s into s upon s square plus 4. So since it is the derivative of a function, we have in the previous video we have seen that when we find a derivative of a function, it is multiplied by t. So d by n dt f of s equal to what? Inverse of it is nothing but t and f of t. Okay, t and f of t. Minus 1. So here since we have differentiated one time, so it give us 1 t minus 1 to the power 1 f of t. Okay, f of t, that is our sin 2t. So that give us t by 2 sin 2t. Okay, now since it is multiplied by s, okay, since it is s upon s square, s, that is d by ds upon f of s, which will be what? Differentiation of, that will give us dt upon t, 2 outside t sin 2t, so which give us the result of 1 by 2 sin 2t plus t cos 2t by t by 2 into 2. So it gives us 2 upon sin 2t plus cos 2t upon 4. Okay, so that is our result of a function. I think you have got it idea of how to find it. So we'll meet another interesting video, so do like, share, subscribe now. Oh,